Okay, hi there. Thank you so much for watching my Epidemiology Research Methods project for Public Health 701. To introduce myself, my name is Emily Schwab, and I am a Master of Public Health candidate at MCPHS University in Boston, Massachusetts. So, my main interest in the field of public health is epidemiology. So, I decided to do my final project for Survey of Public Health on epidemiology research. My project is made up of 5 modules, throughout which we will go over an introduction to epidemiology research, different study designs, measures of association, as well as some basic statistical analysis, and different kinds of bias. My hope for you is that after watching these 5 modules, you'll be able to read any epidemiology research paper and identify what kind of study design was used without being explicitly told. So, in addition to the modules, I also have a training document, which includes a course outline as well as a supplemental reading list and some study questions that you may find helpful. So, let's go ahead and get started with Module 1, which is an introduction to epidemiology research. We'll start with the question, what is epidemiology? And the textbook definition right here is epidemiology is the study of the distribution and determinants of disease frequency in human populations and the application of this study to control public health problems. So basically, an epidemiologist is a disease detective. They study patterns of disease in order to determine what exposures may lead to disease or some other outcome. It doesn't always have to be disease. And then once those disease patterns are understood, measures can be put into place to minimize future occurrences by limiting or eliminating those exposures. Here we have Dr. Jon Snow. I will spare you any Game of Thrones jokes because he is an epidemiologist. He is often referred to as the father of epidemiology because he was one of the first to perform an epidemiology research study in quite a notable way. He was around in London in 1854 during a big cholera outbreak, and he kept track of which households were experiencing this cholera outbreak and traced it back to their water supply, which was the Broad Street pump. And you can see that right here on his map. So basically, he was one of the first epidemiologists to trace a disease back to its exposure. And what he ended up doing was removing the handle from the Broad Street pump so that the cholera could no longer be spread that way. So, epidemiologists aim to find correlations between exposures and diseases. And I want to highlight that there is a difference between the terms correlation and causation. So, causation means that an input definitively leads to an output. And this is really difficult to prove in statistics and research because it is so definitive and there's really no room for error. Correlation, on the other hand, is an input that is associated with an output. The association may be indirect, and coincidence or error is not completely ruled out. So I have an example, a pretty tragic one. So let's say it is super early in the morning and you're tired and you grab your cup of coffee and it's really hot, hotter than you expected, and you drop it onto the tile kitchen floor. So 2 things are going to happen. First, your mug is going to break. Next, your coffee is going to spill everywhere. So, in this case, dropping your cup of coffee caused the mug to break, and it caused the coffee to spill. The mug breaking and the coffee spilling are correlated. So epidemiology research starts with creating a hypothesis just like any other kind of research. And epidemiologists aim to either prove or disprove their hypothesis, provided that their data is statistically significant. A hypothesis in epidemiology relates an outcome, such as a disease, to an exposure or risk factor. Alternatively, a study can start with an exposure or risk factor, and an epidemiologist can hypothesize what the outcome may be. Now, these right here are two different study designs that we will go over in future modules. And the hypothesis is based on what we already know about the exposure and the outcome, which basically means that the hypothesis needs to make sense scientifically. So epidemiology trials can involve action and observation on part of the investigator. These are called experimental studies, and drug trials are a very common example of this, although experimental studies do not necessarily have to be drug trials. It can be some sort of other intervention. But the main point is that the investigator does enact some sort of intervention on subjects. There is some sort of action going on their part. Alternatively, trials can involve observation alone, where the investigator doesn't enact any sort of intervention. And trials can be prospective, which means looking into the future. So it looks like this. If this is our exposure, and this is our outcome, this is right now, down here. So the exposure is happening now, and we're looking into the future for the outcome. On the other hand, trials can also be retrospective. So if here is right now, then the exposure could have happened back here, and then the outcome happened here, but we're looking backwards for all of this data. Often pre-existing hospital data or school data or some sort of public record data is used for this. So let's start with an example. Let's say an epidemiologist stumbles upon the Yelp page of a local ear piercing shop. She reads some reviews and notices that many customers have complained that their ear piercings became infected. The epidemiologist contacts customers and employees of the shop, conducts surveys, and collects her data. When analyzing her data, she finds that the customers who had been experiencing infections had all been pierced by Tom. Tom, unfortunately, did not know how to use the shop's autoclave machine and had been washing his piercing tools with soap and water instead. After the results of the study were published, Tom was retrained on sterile practices, and the shop switched to single-use piercing tools only. The incidence of infection significantly decreased. So let's take a quick quiz. So what was the exposure and what was the outcome? Pause the video here so you can think about that for a second. The exposure in this example was the non-sterile piercing tools, and the outcome was the infection. The outcome was identified first. So next question, was this an observational study or an experimental study? This was just an observational study because the epidemiologist didn't have any sort of intervention. And was the study prospective or retrospective? It was retrospective because all events, including the piercing and the infection, had already happened at the start of the study. So first, we'll go over cohort studies in Module 2. Module 3 will cover case control studies. Module 4 will cover randomized control studies. And Module 5 will cover cross-sectional and ecological studies. Thanks so much for watching Module 1, and I will speak with you next time.